This is Haskell, motherfucker. Okay, Haskell Spartans, let's stop talk too much about it and let's do it. Hi guys, Bitcoin has set a new record, and this is not limit. And in the honor of this we will improve the monitoring of Bitcoin, which I did in the last video. Okay, you can see all this code in Haskell here, and the first thing I don't like, it has some this tricky part, the recursion, and then one function call another function, and so on. I want to avoid this. The second thing I don't like, there are many lines of code here. This is not a Java or Python, and all this literal noise, I want to avoid this.
This is madness! Madness. This is Sparta!
This is Haskell! Okay, Haskell Spartans, let's stop talk too much about it and let's do it. Okay, here you can see some code. I import modules and take some function from the previous video. We need this URL to request the data in JSON, the parser of this JSON. We using JPath to do just a simple query to extract the price, and we will write a simple function which do the request to this URL and do some free delay for 1 second and return parse data. Okay, and this function also handle some HTTP exceptions. Okay, we can see here it's in type signature. It will return either HTTP exception or the string which contains our Bitcoin price, and we're using it using try function. Okay, I just put this function to a try function, and the try function returns me IO value which contains either value with either error or either correct value. The next thing, I need to write some helper function. I will call it PA, and it will take the previous price. I call it PN. Okay, let's call it PP, and it will take value in the case of our success extract from JSON, our price. Okay, and I will call it write P. And how I will define this function, it will return either print action, either empty action. Okay, if our previous price equal to our price, then we print our price, and otherwise excuse me, we just return our price, or just return our empty action. We do empty action, or otherwise we print our price and return our price. Okay, this is definition for this function in the case if we do successful extraction of the price here in the result of this function. This either is built to be a right constructor, and the pattern match it here. Okay, but we also need a case then the error is happened in HTTP requests, and we will handle this here. And also we need previous price, but here we catch the value built the left constructor of our price. And how we will define this function? Okay, error is happen. First of all, I want to print this error. And the second thing, I want to do a delay for 1 second. delay for 1 second, and the next thing I want to just return this error. And of course I need to define what error is, and the error is just show our value inside the left constructor. And I think this should work. Let's try to compile this function and look at its type signature. Okay, I load my module boolean3. Okay, I need to correct this equal sign here and some problems. Of course, here I need to return a price not equal, not anti-double, because I need this price later to check, to use it as a previous price. Okay, and let's try to load this. Okay, and it's compiled. Now let's look at its type signature. Okay, you can see that this function take a string, it's a previous price, as a first argument, then it takes either some showable t or string and produce IO string. So this function takes previous price, takes some result from act function, either error or successful value with price, and produce a IO action with which contain what we want to do in these cases. Okay, we want to print an error, or to print a price, or not to print a price if it equal to a previous price. And if you can see a type signature of this function, of this part of function, you can see that this is a monadic function. Exactly, this is a monadic function. And this tells us that they can use it with the binge operation in monad. Okay, and now let's look at some interesting function. It call its name is iterate until m function, and this function exactly the key how can we express do it in expressive way, do all chaining of our actions and state which flows through the sections. I have already made a video about this function, you can see a link in the description. How this function works. Okay, it's takes some function as a first argument. It's some predicate function. It's defined then to stop iterations. And in our case, I want our iterations repeat infinitely many times. So I will provide here the function which always return false, because I want my iteration goes infinitely. And the interesting part is the second and third arguments. The second argument is iteration function. And you can see here that this is a monadic function. And the third argument is initial value. So we give to it the initial value and give to it the monadic function. Okay, and all it's do what's it's take this initial value, put into a monadic function. The monadic function produces action. The action is performed. The inner value of monad extracted, and again this new value put into our monadic action, and so on and so on. Our monadic function will call again the new value of the previous monadic call. Okay, and you can see that this pattern exactly what we need. We can chain our previous price through our actions here. Okay, let's write this. Iterate until m. Okay, the first argument. As I said, I need a function which all this return false. I want my iterate infinitely many times. And the next is exactly the function, a monadic function, and it takes a previous price, and it must produce an action. And for this action we already have these helpers, and let's use them. Okay, first thing, okay, of course we need to perform our action, this action, and then it is a monadic value, and we can pass it to our helper function with previous price. So I just partially applied here, and I've got type signature which exactly can handle this action via bind operation. And I think it's done. Okay, all I need to provide a start initial value, and I call it start. Okay, let's try to run this. We can see maybe some errors. Okay, I reload the module and it compiles. Okay, and let's try to run it. I just run main, and you can see that Bitcoin price is extracted as expected. Let's see what happened if I turn on the internet now. Oops. I turn it off, and you can see that our program handles our exceptions. We print them on the screen, okay? And if it not fails, it continue to try to extract the information. And if I up my internet, okay, we can see that Bitcoin price here, and it survived this situation. It handled errors correctly. Sorry. Okay, Haskell Spartans, this was a simple Bitcoin monitor. I think you enjoyed, and push like button, push subscribe button, write comments, and see you in the next video. This is Haskell, motherfucker.